Meet Jen. After finding out her interest in electrical engineering was purely academic, she switched gears. Her JD looks great on the wall next to her master's. Jen went on to become a patent attorney, where her services are in high demand. She helps many clients year-round with taking their inventions from prototype to patented intellectual property. Patent law is a subset of intellectual property or IP law. IP covers four major topics: copyrights, trademarks, trade secrets, and patents. There are approximately 1.5 million IP lawyers in the United States today. Jen is just one of approximately 20,000 patent lawyers in the United States. She has her work cut out for her. In the US, the demand for patents continues to skyrocket. Over 660,000 were filed in 2019. Globally, the trend is mirrored. In 2018, 3.3 million patents were filed worldwide. Like all patent lawyers, Jen's in-depth legal and technical knowledge ensures she is in high demand with clients. But with the amount of patents filed only growing, and Jen's own client base growing, she is concerned about continuing to be able to deliver the best patent-related advice for her customers. Jen, we're here to help. Allow me to introduce you to PatentNet. The PatentNet team is made up of Jules Lambert, Zach Nguyen, and Dougal Percival. The team is bringing years of experience in the fields of AI, machine learning, and data engineering to help revolutionize the patent law industry. PatentNet is working towards one key goal, so that Jen will have confidence in her patent research. Jen works 50 to 60 hours in a given week. She charges a flat rate of $4,000 to $6,000 per patent application. Patent applications can be split into three sections: research, filing, and working with the client. Due to the rigorous investigation that is required to file a patent, about 25% of that time is spent researching material related to the case. Another 10% is spent on actually filing the application. The remaining 65% is spent working directly with the client. Because of the time commitment, Jen can only take on 4 to 6 clients per month. Are Jen and PatentNet a match? Absolutely. We estimate that PatentNet can save Jen enough time on research and filing applications that she could take on an additional month's worth of clients each year. Extrapolating to the 20,000 patent lawyers in the United States, the value created here is between $400 and $500 million. With this market cap, we estimate being able to license this product for around $4,000 per year.
Well, how do we save Jen time? Since a lot of her time is spent on understanding the patentability of a technology, we develop a similarity search engine to help her find existing ideas which are similar to the invention in question. We can also reduce the load on patent filing and decrease the chance of rejection by automatically extracting information useful for filing and validating her patent application. So for example, during our discovery, we found out that patent lawyers are required to fill an information disclosure form, in which they have to disclose specific points of similarity between the said invention and previously granted patents. Our algorithm can automatically detect for these. So how do we do it? Let's start with our data. PatentNet leverages available open source data to build a patent network and patent tags. The Patent Citation Network from the U.S. Patent and Trademark Office provides us with a graph of citations between all U.S. patents. The USPTO also provides us with detailed information, including the abstract and the full text. We made use of a subset of all citation data from 1990 to 1999, with data from almost 1 million U.S. patents. Here's the pipeline for our product. We use a variety of NLP and GNN techniques to build our features and train our model, as you can see. Most notably, we use a node-to-vec algorithm on the citation network to achieve a good performance on identifying similar patents. The graph data structure allows us to find patents with citations many hops away, but are in the same neighborhood. We also applied a simple graph convolution to classify patent technology class, which can help lawyers validate their patent applications. The graph convolution with TF-IDF node features reduced to 128 dimensions improved performance by 9 percentage points over the logistic regression baseline, which uses only natural language features. Jules will give us a demo of the product.
So we will show a demo. Here's an example of a search. If we say we can search by the years, so we have some limit of the 10 year right now, we have data, and we can say that it look on the citation or based on the text. So here we'll do a search that is based only on the citation, and we can look the result, can link to the patent of the website of the US patent and see the stuff. So this is based on the citation. So if they are either cite themselves or have the same kind of citation, and we can look the kind of the result. Some like say the beginning was more better and the last were, let's say, less good. And we can look for other example. Here, another example, again, citation. So the citation is based on multivec. And again, we can see these are some stuff with break from stuff, so all kind of stuff that are on break. The example here were cherry picked, but it still kind of seems to work here. Also, we can base it instead of on the citation, based on the text. The text is based on TF-IDF with the SVD, and we see still some result. So the break still kind of that are still similar a little. And if we want, we can even put like half the weight of the search is done with the citation and half is done from the TF-IDF. And we can have so different value that we get. So we can kind of play with this, and do we want more weight on the citation or more in function of the text, and we can play on that.
Over the course of the project, talking with our users, we learned much about our market and the implication to our product. First, patent dispute and lack of novelty are cited as the main reasons for patent rejection. This has allowed us to focus on useful features that relates to that problem. Second, cross-lingual patent search is a huge challenge in the globalized world, with countries like China and Japan granting increasing number of patents. This made us realize our limited data, despite its size. Clearly, there's a huge opportunity for machine translation in this area. Third, we realized that lawyers might not be our only market, as many inventors actually file patents by themselves. Last, the feedback we received clued us into the limitation of our method, which is our evaluation. We realized that our results should be rigorously tested in empirical settings to prove its value. Based on these feedbacks, we provided a rough plan for future work. We will do more testing and validation with patent lawyers or those who have experience filing a patent. We will also try to expand our data to incorporate at least a 20-year span, which is the lifespan of a typical US patent. We will do research and expand our feature set to closely match lawyer requirements, as well as spend more time and computation to experiment with more complex neural network models in both graph theory and NLP. That's it for our presentation. Thank you for listening.